Right, welcome back to the channel. If you watched the previous video, I do realize that the mic of me typing it's kind of horrible. So I didn't get my mic yet, but I try and get one just to continue to get good videos. Right. So today's video is 5 missing observations. So you're given n plus m six-sided rows thing, and then you want to find the average of calculating n plus m. So you're given the rows, and then you're given a mean, and then you're given an n. So m is basically the length of whatever rows array they give you, and then you want to add n of them into it to make it such that the average value of n plus m rows, the sum of it will be the mean that given. So let's say in this example, you're given 3, 2, 4, 3, which sum up to be 12, and then you want the mean to be 4, and then you want to add 2 missing rows. So in order to make it to be 4, you want to get a 6 item, so you want to get this 12 plus 2 unknown, and then divided by 6 will be equal to 24. Divided by 6 will equal to 4, which means the total sum of 6 things need to be 24. And then you can find that in order to achieve it, you can only put 2 6 in here. Another thing is about this, which they also said that the order doesn't matter, or if there are multiple valid answers, return any of them. So if no such array exists, so return an empty array. So let's say in example 3, you have 1, 2, 3, 4, mean equals to 6, and n equals to 4. You know that in order to achieve something that has a mean 6 in a 6-sided rows, means everything needs to be 6, right? So this is impossible for them to happen. So you just return an empty array. So let's dive into the code. I am going to use a greedy way to do it, which means whenever I have a lot of things to put in, I can just put a bunch of it into it. So let's start with this. I define the code to be total required. Total required means that I want the mean multiplied by the length of n plus m, which we know is the length of rows, which is the m, and then plus m. And then we can find the total to be the sum of the rows, and then we can set the required to be the total required minus total. So in this case, we can see that the total required for case 3 will be equals to 6 times 8, like 48, and then the sum will just be 10, and then the required will be 38. I believe. Okay, so we can just try to print this out. Actually, I think it should be the other way around. So total required, and then we can print out total, and then we print out required. All right, for case 3. Yep, so you can see that you require 38, and then this is 48 and 10. Yep. So one thing you can check is if required is greater than n times 6, which in this case you have 4, and then 4 times this case is 4. So 4 times 6 is 24. So your required is already greater than 24. That means it's not possible for you to get it anyways. All right. So this is one case, or your required is less than or equals to 0. So if it's less than 0, we cannot roll a negative dice. So that's not possible either. Or our required is less than n times 1. Means that if we put everything to be 1, there will still not be enough, like 1, but then we have not enough. We have to put at least 1 0. So that wouldn't be not possible. I'm sorry for that. You can actually put all to be 1. Yeah. So in this case, we just want to return an empty array. Let's comment this out. Okay. So we can set result to be an empty array. I can also set it before, and then I just return the result. But either way is fine. All right, and then we can set. Let's zoom in. All right, we can set while n is greater than 0 because we want to do it n time, and then we can set needed equals to n minus 1. Why am I doing this? It's because let's say I want to do I'm saying that I want to do a greedy way, right? So if let's say I have 13, right? So greedy way will be put a 6 right here and then put a 6 right here and put a 1 right here. But we found out that oops, we do not have the remaining to put it in the spot anymore, right? So we want to use the needed equals to n minus 1 to make sure that we have at least enough for the remaining. So let's say in this case, I see I have 6 remaining right here, and I was like, okay, sure, I needed 6 remaining, and then maybe I can just put 6 right here. And then when I come to here, I have 7 remaining, right? And I was like, oh wait, actually, and if I put 1 here, 2 here, another 1 here, another 1 here. If I put, maybe I need a different color, right? Let's say if I put 1 in all these places, right? I need 5 of them, so I cannot just put 6 right here. So the max I can put is maybe 2, right? So there will be 3, 4, 5, 6, 7. Yeah. So I'll just put 2 here, and then there'll be 13 minus 6, 7, 7 minus 2. We have 5 left, and then we can see, oh, there are 4 needed here, so we can just put 1 here, and then we just put 1 for the remaining. All right, let's back to the code. This is what I said by needed, and then we said if required is greater than equals to needed, which I think it should always be. And I said current will be the mean of 6, and then required minus needed. So see which one is less, right? So let's say my required is greater than equals needed. I have like 7, but oops, this is not the case where my minimum is I have 6, but I have 7, but my required minus needed is just like 2. So I want to put that to be 2 instead of 6. And then I just want to append the current, and then required is minus equals to current. And then we can do n minus equals 1. Then we can just return the result. I put this in the beginning because I didn't include one of these case before. So let me run this and see if I can get rid of this line and then still make it work. All right, so this should be the code. All right, thanks for watching the video. And then I hope you have a fun time continue Leetcode and continue through the summer. I'm from the school using quarter system, so my schools haven't started yet. But if you have started school, yeah, just continue to do Leetcode if you're looking for next year internship. It's good luck on Leetcode Grind and good luck on job searching.